sounds like university students just having fun, and they do, but there is a practical side to this.
There's tremendous innovation here. We're actually advancing the state of the art here. We're not just pushing ping pong balls around on a table. We're doing things that have never been done before.
The University of Waterloo Aerial Robotics Group was formed in the fall of 1997. The group is comprised of dedicated and ambitious students across the disciplines of electrical, computer and systems engineering. The group is representing the University of Waterloo in the International Aerial Robotics Competition of the Millennium.
The goal of the Association for Unmanned Vehicle Systems is to really push the envelope of technology forward. And to do that, they put together a 3-year competition where they're asking the universities to design a team of aerial robots that navigate autonomously through the air and pinpoint the location of victims of a disaster site.
So you can imagine how intimidated we were when we were presented with this challenge. We actually even questioned our ability as a team to perform and to compete against other top international schools that already have a history of excellence in technical competitions such as this one. But that didn't stop us. We embraced the challenge.
I'm really happy at the University of Waterloo that we're able to have these type of interactions between students and industry. The students can learn about real-world problems, and industry gets a first-hand look at some of the quality students that we produce at the University of Waterloo. We've always had a fine tradition of this, starting from our co-op programs all the way to the number of spin-off companies that have come from graduates from our program.
To complete this mission, WARG is using a highly modified remote control helicopter. This helicopter is outfitted with a GPS, various orientation sensors, a Pentium single-board computer, and a 2-camera vision system. The robot must consist of sufficient technology to search for and identify people, while remaining light enough to fly. After much work, the first prototype of the helicopter flies through the air under the control of a trained human pilot. Algorithms for flight control, image processing, and sensory integration bring the helicopter to life. Persistent design and testing results in continuous improvements in the aerial robot. 3 days before the WARG crew must leave for the 1998 competition qualifier, the helicopter soars through the air, carrying with it the hopes of the team. The group watches in horror as the helicopter loses control and heads towards the ground. Thankfully, the specially designed lightweight landing gear prevents any serious damage from occurring. After a minor tune-up, the helicopter is ready for the trip to the competition. Budget constraints allow just 2 team members and a pilot to escort the helicopter on a long journey across the continent to Richland, Washington. The competition was held at Hammer Emergency Response Test Facility. Hammer has a complete arsenal of obstacles to avoid during the mission. Smoke, giant water spouts, burning landscape, and deadly scorching flames. Even the animatronic victims were frightening. Fearful, yet inspired by the intensity of the disaster site, the WARG team members attempt to prepare the helicopter for a pilot-controlled flight through the disaster area. Spectators and the media watch intently as the schools attempt to demonstrate their progress thus far. Competitors from Simon Fraser University, USC Berkeley, MIT and others cannot get their robots far off the ground in the intense Richland heat. Some attempts even ended with disaster. After watching the shaky results, the University of Waterloo was the only team to soar its aerial robot over the disaster site to the delight of spectators, competition organizers and the media. After the competition day and design judging ended, WARG had achieved the second highest score and was also awarded for having the solution with the best overall innovation.
It really is amazing to me when I think back at all the long hours and late nights we spent working on this project.
I mean, a lot of people have put in a lot of time and a lot of effort to get us to where we were, and we're really impressed with our accomplishments.
And we're not the only ones that are impressed. We found that when we were at the competition, we really garnered a lot of the media attention. The media and the judges and the other teams really seem to like our solution, and I feel like we're one of the favorites.
And this also helped us gain some more confidence than we had when we went down there. And really, we're at a stage now where we know where we sit relative to our competitors, and we really think we can win the competition in the year 2000.